try to explain you this. This is the initial value of the exchange rate, S0. This is the value of the exchange rate, which can be explained by economic fundamentals, by the exogenous variables. If the exchange, okay, I can write this way. If the exchange rate is exactly equal to 1 over alpha 2 integral between 0 and t omega v e to the power of minus v over alpha 2 in the v, in this case, we have an equilibrium in the exchange rate. Okay? But if the exchange rate is greater or lower than the part which depends on the exchange rate, the problem is that the exchange rate goes to plus or minus infinite. Okay? As times goes to plus infinite. So this is just a way to show you how to solve the differential equation, and that we need to solve the differential equation between t and plus infinite. So forward looking between now and the future. Now and the end of the universe. Okay? This is the problem. But this problem was clear just in the initial differential equation, because the initial differential equation was s dot t equal to 1 over alpha 2 st minus 1 over alpha 2 omega t, and we have this phase diagram. We know this, so we know the instability of the equilibrium solution. Okay, now I give you the forward-looking solution, because we can compute here the forward-looking solution. But the forward-looking solution is a solution between t and plus infinite. So we need to consider the future. And the forward solution is st, the exchange rate, equal to S0 minus F0. I'll explain you what this means. Plus Ft, sorry, this is multiplied by e to the power of t over alpha 2. Okay, I define Ft is 1 over alpha 2 integral between t and plus infinite, so forward looking between t and plus infinite, omega v e to the power of minus v minus t over alpha 2 in the v. So this Ft is the discounted value of the economic fundamentals between t and plus infinite. It is also called the fundamental solution of the exchange rate. Yes? F0 is easy to understand now because F0 is 1 over alpha 2 integral between 0 and plus infinite omega v e to the power of minus v over alpha 2 in the v. This is the definition. But so F0 is the discounted value of economic fundamentals between 0 and plus infinite. Ft is the discounted value of economic fundamentals between t and plus infinite. This equation is crucial because this gives the dynamics of the exchange rate, including also the expectation about future value of the economic fundamentals. It's not just the backward-looking solution. Now we include our expectation about future exogenous variables in this model. But we need to consider also the future exogenous variables because we need that the exchange rate can jump on the equilibrium. I try to explain again. Solution is exchange rate equal to the initial value of the exchange rate minus the value based on fundamentals, okay, which multiplies e to the power of t plus over alpha 2 plus the value of the exchange rate based on fundamentals at time t. Now, if the initial value is greater than the value explained by fundamentals, by exogenous variables, this implies that St goes to plus infinite as t goes to plus infinite. If t goes to plus infinite, the exchange rate goes to plus infinite. You can see. Because this factor is positive, this factor increases over time, so you go to plus infinite. If S0 is lower than F0, this implies that as t goes to plus infinite, the exchange rate will go to minus infinite. Okay, because the first factor is negative. So we need to impose, in order to have a stable solution of the exchange rate, we need to impose that St is equal to Ft. So we need to impose that the value of the exchange rate is equal to, at time t, is equal to the discounted value of economic fundamentals at time t. Imposing this, we will solve the exchange rate in many hypotheses of monetary policy. We are able to see the dynamics of the exchange rate in this case. The first part of this equation, S0 minus F0, is also called the bubble term. It's the same as in the financial market. You have bubble terms. The bubble term is the term in which prices increases forever. we need to impose that the bubble term is equal to 0. We need to impose that the exchange rate is based on fundamentals in order to avoid the explosive dynamics of the exchange rate. So we need to impose the condition that ST is equal to 1 over alpha 2 integral between 0 and t and plus infinite, sorry, and plus infinite omega v e to the power of minus v minus t over alpha 2 in the v, the discounted value of the economic fundamentals at time t. We need to, this is the economic fundamentals, this is the discount factors, so this is the discounted factors, the discounted value of the economic fundamentals between 0 and plus infinite. We need to impose this condition. Imposing this condition, we are able to determine the dynamics of the exchange rate. Now we will see different hypotheses about monetary policy. For instance, if we will assume that all the other exogenous variables are equal to 0 in logs, so we simplify, okay? And we can see what is the dynamics of the exchange rate if, for instance, the nominal money stock is assumed to be fixed forever. What is the dynamics of the exchange rate if we assume a sudden increase in nominal money stock forever? What is the dynamics of exchange rate if we assume a temporary increase in nominal money stock? What is the dynamics of exchange rate if we assume a future increase in nominal money stock? And this is enough. Okay? After the break. Okay?